Hello boys and girls, this is your video for your lesson today, which is really funny because you guys are sitting in the room and it's pretty funny. So anyways, turn to this page. I don't know what page it is in your booklet. Oh, I guess it's 55 in yours. So today we're going to talk about linear transformations. So remember to transform. Trans means across, so we're going to be moving graphs. Okay, these are rules you're going to memorize from now until the end of the year. We use them with all sorts of functions. So we have a parent function, okay, and then we change something about that parent function that moves the graph. So you have parent function f of x equals x, which is this line, and then they change the y-intercept by changing b. Okay, so the graphs have the same slope but different y-intercepts. And then when you change the slope, you change the steepness of the line. So that's what it's showing you here. Okay, so you can read through those on your own. So down here in the examples, it wants us to compare the functions below to the parent function f of x equals x. So remember, that's just function notation, so it's really just y equals x is our parent function, or the same as this function right here. So when I go to graph this, if I'm going to graph this according to slope-intercept, y equals mx plus b, m would be 1, mb would be 3. So I start off at 3 on the y-axis, and I count up 1 over 1. Okay, so that becomes my line. And I lost my ruler. Ruler. Well, looks like I'm going to be using sticky notes. Okay, so that becomes my line, g of x equals x plus 3. So the graphs have the same slope. M is the same in both of them. Therefore, the lines are parallel. The y-intercept of g is 3 more than the y-intercept of f. Okay, so it is y-intercept of f. So this should say, so g is a vertical shift up 3. Okay, or a vertical translation. You can even just say shift up 3, that would also be fine. So here y equals 2x, my slope would be 2, my y-intercept would be 0. I graph that. Okay, and label it h of x equals 2x. So the slope is 2 times more than the slope of the parent function. So our parent function was here. The slope here is 1. The slope here is 2, so it's 2 times more. The y-intercept for both of them is the origin, or you could say the same. Oh, actually, let's just say is the same. Let's say the same there. Is the same and passes through the origin. Function h is a stretch of function f. Okay, and let me show you. If you're looking at them on your calculator, remember we go to y equals, make sure nothing's turned on. Everything is out of here, and you can put in the parent function, so y equals x. You can graph it. Make sure you're in standard zoom. If it gives you an error, go to zoom, standard, or 6, regraph it. Okay, now my calculator graphs in color, so it's nice. I can put in x plus 3 underneath it, and I can tell the difference. So you can see it moved up 3. And then I can put in 2x underneath that in a different color and see that it got stretched. So if it was blue and I stretched it out, I would expect it to get longer. If I smush it in, I would expect it to go more flat. And we call that smushing a compression. Alright, so these are the rules. And these are the same rules we use for like our next 3 units. So you really want to make sure you memorize them. So whenever we put a number out behind the x, if it's positive, it'll be a shift up. And if it's negative, it'll be a shift down. So this moves up, this moves down. If I put a number inside the parentheses, it moves opposite. So this is plus, but it moves left. This is negative, it moves right. So it moves left and right opposite of sign. So plus is left, negative is right. If I put a negative out front, it's a reflection over the x-axis. When my number out front, my coefficient, is greater than 1, it's a stretch. When it's between 0 and 1 or a fraction, it's a compression. Okay, so those are going to be memorized. So right here, this is saying, if we graph both f of x and g of x in the same graph, state the transformations that have taken place and f of x equals x. So this is my parent function, which is really y equals x. Okay, so g of x is going to be the same graph of f of x, but with a plus 2 in the back. So that means that I'm going to shift up 2. So I'm going to do f of x, my original. Oh, sounds like it's time to go. I'm going to have to pause our video. Hold on.